afternoon round of the presentations. So welcome back, and if you weren't here this morning, welcome. I think you're going to like what you see this afternoon. We've got some good teams and some good projects that they've accomplished. First up is one of Dr. Lara Gracia's teams. And Marco, I'll hand you the mic and let you introduce your team.
Thank you so much. Well, good afternoon. It is my pleasure to present this great group of students who did an outstanding job this semester working on their senior project. They are Casey Montgomery, Nick Theodosis, Kyle Wilkinson, and Kyle Bigler.
Thank you, Marco, for the introduction and everyone that has showed up today. So our senior design that we've been working on for the past few months is Testing Center Solutions for Flanders North Plant. Give you a background first of Flanders. For those of you who don't know, Flanders is headquarters right here in Evansville, Indiana. They manufacture and repair AC and DC motors for industrial applications. And they're used in various operations, including mining, manufacturing of steel, plastics, aluminum, pretty much any material that you can think of, as well as they're in the transportation and alternative energy industries. Kind of give you an example, an idea of how large these motors are. This is one of the manufactured motors that Flanders has done. It's a 2,500 horsepower unit that's used in a steel mill operation. Motor testing is very, very essential to Flanders' operation, if not the most important. Flanders realizes this, and by doing that, they exceed industry standards when it comes to testing their motors. They have the ability to simulate motor testing in-house, how that motor will actually be, how it will actually undergo actually out in the field. Here's an example, a table of just the milestones during completion for AC and DC motors. The kind of what to get away from this table is that these are the tests that have to be complete, that have to meet not only industry standards, but also customers' expectations before a motor can be sent out to the end user. This is an example of their current test center. Down below here, as you can see, these are the motors being tested. Up above in an elevated room called a pulpit, this is where the employees testing the motors will be located, so they're out of harm's way of any arc flash or any flying parts that might happen during the testing operation of a motor.
Currently, their operations, their manufacturing is done in this building, and their testing is done in a separate plant across a parking lot where they have to transport the motors to after they've been manufactured. They also will test their repaired motors here. This new test center will be in what they call their north plant, which is right across from their manufacturing plant. Currently, there are some areas for improvement. Right now, their manufacturing and their testing are in separate buildings, which can be an issue. They're sharing equipment between these facilities, and their visual display right now is only displaying technical data, nothing to show where they stand in the testing process. Their overhead cranes are kind of their bottleneck right now. They're being used by multiple departments. Their testing is also done from personnel from multiple departments, so they need to bring people from, take them off of other jobs to do their testing, and also just overall customer service. Currently, this new test center is in the process of being built. The plans to be done this summer and be fully operational by the end of the summer. And their goal is for it to be a benchmark for their other regional testing centers and possibly globally.
Okay, the scope for this project, we wanted to improve the process flow for the North Plant test cell by decreasing time spent actually testing these motors, and also visually display the current testing procedures being performed in real time for the benefit of both the employees at Flanders and their customers as well. Our deliverables, we're proposing a layout and storage system to help reduce time spent actually looking for items, retrieving items within the test cell itself. Material handling system. This will help reduce time waiting on equipment essential for transportation of these large electric machines. A staffing structure along with a process improvement plan. This will help reduce time actually waiting on the personnel required to perform these tests on these motors. And finally, we have a barcode scanning-based data system, along with a visual display to provide the status of jobs in real time.
So the first area we looked at was the actual work cell design and the storage system around the work cell. The goal is to modify the work cell to flow efficiently and sufficiently and provide sufficient storage for any equipment using 6S principles. The goal is, or the benefits are to maximize the flow of motors through the work cell, increase throughput, keep any necessary equipment needed for testing within reach, and to minimize time spent searching for equipment and have a well-organized work cell. So as I mentioned, 6S principles, you've got sort to remove clutter from the work cell, simplify, organize the items in a logical manner, shine, keep the work cell clean and, like I said, free of clutter, standardize, to standardize the practices in this particular work cell, also throughout other cells in the facility, sustain, to make this process a part of the culture throughout Flanders' entire operations, and safety, obviously concentrate on safety being a top priority. So with the storage, we want to utilize, there are shelving units to the north of this test cell, which will be shown in a layout in a minute. And tools and any equipment will be utilized on like a most used basis. These shelving units, they stand about 13 to 15 feet tall, depending on how they're set up. And anything that's not used very often will be near the top, so it won't be in the way of the stuff that will be more often used near the bottom. There's also open space in front of these shelving units that can be used. That needs to be utilized strategically, however, so you can still get in with work trucks to get anything on the shelves. And this is a drawing of the shelving units that I just mentioned. As you can see how tall they are and the overall area we have to work with. Another area will be the storage underneath this pulpit, like Casey mentioned earlier, is just an elevated room where a lot of the controls will be done for the testing. We want to utilize the space underneath right here. It's not being used for much besides for some electrical components. We used it mainly for personal protective equipment, which needs to be utilized very quickly in the case of an emergency. Also for any small tools or any documentation. And we're planning to utilize a cabinet, a simple cabinet to house all this. The other area is the actual layout of the work cell. Obviously the goal is to move freely and safely throughout the work cell and keep everyone out of harm's way and moving efficiently. We want to leave everything in the work cell machine accessible, meaning overhead cranes, any pallet jacks or fork trucks, so that they don't have to, nothing has to be moved to get to anything else. And also leave an open path underneath the pulpit so personnel can move in and out from the AC and DC sides of the test cell. So here's the layout of the actual test cell. Up here is the AC side where AC motors will be tested. Down here is the DC side. Obviously DC motors will be tested here. This is the pulpit that I mentioned earlier. And as you can see, there's plenty of space for everything to be moved around and moved efficiently.
The next deliverable is the material handling assessment. The goal is to reduce time waiting on equipment. The benefits are to improve the material flow, increase safety, and also reduce the dependency on the overhead cranes. The proposed solutions would be a walk-behind fork truck, an electric pallet jack, an overhead crane, and also a wall bracket jib crane. The material here, or equipment here, is a walk-behind fork truck. It allows the workers to be able to get material off of the shelving units that Nick previously mentioned. The equipment over here is a electric pallet jack. This will allow the workers to move the equipment around easily without needing to use the walk-behind fork truck due to the larger size of the walk-behind fork truck. This is an example of the 20-ton double girder jib crane that they currently have in Flanders. The goal would be to add one more onto the DC side. As you can see, it moves along these beams up and down the bays, which you will see in the next slide. overhead crane. It allows the green area shows the area where the overhead crane can move. It allows for 100% coverage throughout the whole entire test cell. We'd only like to implement one overhead crane above Bay 4 due to the increase in production that they will have over there. Here's an example of a jib crane that they currently have. We'd like to implement two of them in the test cell, one on each I-beam, as you will see in a minute. Here, the green area on here shows the area that the jib crane is able to cover. The gray shows the area where it is not able to reach. This is due to the pulpit being over here, and also the jib crane only reaches 180 degrees. We chose to use a 20-ton jib crane, or 20 feet jib crane, due to the fact that it can reach out into the aisleway, and this will allow workers to stay out of harm's way and be able to reach the equipment out there.
The next proposal is a staffing structure. The idea, the goal of the staffing structure is to have employees that are ready to test a motor at any given time. The benefits of having testing or a staffing structure that is to test motors only, that is their key responsibility. One of them is scheduling. So currently with scheduling, they're having to schedule employees from different departments. It's just not very efficient, so it'd be a lot more efficient by actually having a department that's dedicated to testing alone. You have the ability to test both AC and DC motors simultaneously, as well as better communication. Kind of goes with scheduling, but if you have a set testing department, that allows for better communication on even the customer side of, if the customer requests a motor to be tested, they know where to go as far as get the information on how long that motor is going to test, because there is a set testing department. And then, of course, overall customer satisfaction. It looks more appealing to the customer if there's actually a testing department opposed to actually having to get individuals from different departments to test their motor. Here's an example of the proposed staffing structure. Up top is we'll have a departmental manager. The departmental manager will oversee the entire testing operation, making sure that all personnel are meeting their deadlines, as well as he'll be the communication between the individuals on the process floor, upper level management, and all other departments within Flanders. Underneath him will be AC and DC lead technicians. They should have the knowledge to be able to test a motor from start to finish. And underneath them is you have AC and DC support technicians, and they'll aid and guide and support the AC and DC lead technicians in completing and testing of the motor. This is a process flow chart from when a customer requests a motor all the way to the start of the production of that motor. So a customer requests a motor to be manufactured, and then they'll be then assigned an account manager. That account manager will then send that request to a proposal engineer. That proposal engineer will have constant communication between the manufacturing department and the newly proposed testing department. And they'll constantly feed back to the proposal engineer to make sure that what the customer requests can be completed and can be completed in the time frame that the customer wants. When all parties agree on the final product order, then start of production will begin. The next proposal that kind of goes along with staffing structure is a continuous process improvement plan. The goal of a continuous process improvement plan is solve operational issues as they occur. The continuous process improvement plan that we have chose is Workout. It was first developed by General Electric. It makes individuals closest to the process accountable for solving or for improving the process. It allows for boundaryless behavior. So there's an open door policy from the individuals on the process floor all the way to upper level management. When there's an operational issue, everyone knows, not just the person on the floor. It allows for a rapid response of observing the operational issue to a rapid response of solving that operational issue. And we have sent full implementation details to Flanders for them to take a look at.
Visual controls and data acquisition. Our goal in this facet of our proposal is to propose a visual control system to improve the information sharing within the plant at Flanders and allow for better communication with the customer, the end user. Some of the benefits associated with this system, Flanders will have the ability to share information in real time. And it's important to note that the testing of these motors can take days at times to complete. So that's why it's so essential that these milestones be captured. Better communication for both internal and external customers. What we mean by internal customers is, say my boss gave me a task to do. At that point in time, my boss would be my internal customer. External customers, we just mean simply the end user of that product. And then collecting data to improve the future. We need to define a visual display product that will seamlessly integrate with what Flanders currently uses. Flanders utilizes an enterprise resource planning system, that's ERP for short. What this system does is it tracks the progress of the motor from design to completion and each step in between. The proposed system can be integrated with the ERP system to not only collect data, but to also provide that visual representation of the testing center milestones. And here are those milestones again, as we saw previously on slide number 4. On the left, we see the AC motor milestones. On the right, the DC motor milestones. The only difference between the two is that the DC motors require that brush conditioning be done and also a load test be performed. And here's an example of what Flanders would see on their visual display in the test cell, one for the DC side and also one for the AC side. Up top we have the motor ID with the serial number of the motor. We have the personnel, that being the lead AC or DC technician. The current milestone being performed and also a timer to show how long they've been on that particular step. And this is a simple process flow chart to show what the actual personnel are going to go through when they're testing this motor. So the first thing they would do is they would scan the motor, whether that barcode be on the motor itself or with the paperwork that follows it through the process. Next, the personnel would be scanned, and finally the milestone. And then they'd ask the question, is that milestone complete? If not, of course they would continue testing. If so, are all milestones complete? If not, you come back around simply and scan the next milestone. If so, if they are all complete, then you know your testing process is finished. And here's the wireless barcode scanner that we chose. It's the industrial model. We chose the wireless model because it gives a little more freedom for the technicians to walk around and be able to scan things further than 2 to 3 foot away from the enclosure. And on the right, we see the barcode scanning sheet, how that would appear to the user. Up top, we have the personnel. We have the milestones, specifically the DC milestones here, a complete barcode, and also some miscellaneous ones for lunch and end of shift. And here's that North Plant test cell. We're looking at the DC side. This is the DC pad here. In the upper left portion of your screen is that visual display that we looked at earlier. And then below that is the electrical enclosure that would house that barcode scanner and also the sheet to keep it free from debris.
So the economic analysis weighs heavily on time savings. Untyped here, these are the budgetary costs for each proposal, as well as an estimated annual cost. On the yearly savings, we estimate for a work cell design and storage that there's going to be a half an hour saved per employee actually out on the production floor by having all tools very accessible and all documentation accessible to look at. And that gives us a time savings of 500 hours yearly and a yearly cost savings of $17,000. For material handling, we estimate an hour saved per day during the week because of having the jib crane available and not having to use the overhead cranes. We estimate an hour saved a day. The workout session, it's a negative time savings because that is time that's actually taken away from production, that those individuals actually be in a meeting going through the workout session. But as far as cost savings, GE estimates that for whatever the cost is of a workout session, that the payback is 10 times greater than what the cost is. So you get a total time savings of 670 hours yearly and a yearly cost savings of more than $35,000. This is our payback analysis. As you can see, a payback without production increase, a little less than 4 years. With a production increase, because of the hours saved, you could easily test more motors and get them out to the end user. Just a payback increase of one AC or just one DC motor, you're looking at less than a year payback for the proposed ideas.
In conclusion, we would like the implementation of these proposed solutions will decrease time spent on scheduling, motor and material transportation, communication, and also organization. We recommend Flanders utilizing the proposed solution as a piloted program, and then if that is successful, then transfer that over to the South Plant and also regional service areas and also local.
We would like to thank our liaison, Matt Conville, who's not able to come today, but he has really helped us along this whole project, has answered many emails that we have sent him, as well as set up meetings that we have had with Flanders. I'd like to thank two of the Flanders representatives in the audience today, Randy Davis and Todd Shute. We really appreciate you guys coming here today. We'd like to thank our faculty advisor, Dr. Marco Lara Gracia, for helping us along and being very involved in our project. We really do appreciate it. Dr. Zane Mitchell, the department chair of engineering. Donna Moore for making sure we had the proper paperwork and that we'll be actually walking the stage this Saturday and graduating. We appreciate that. And all professors, families, and friends that have been with us and have supported us through our college career. We appreciate it. Thank you.
All right, we'll go ahead and open it up for questions.
Nice job, guys. Your organizational structure seems to be perfectly parallel, cut between AC and DC. But your motor test list shows the DC requiring about 40% more testing. So do the different production levels account for that mismatch, or is the DC guy going to be mad that the AC guy's sitting around while he's still working?
So right now, this is going to be a piloted program. They're still doing repair motors in the South Test Cell, so it's not completely going away. So we see that if the individuals on the AC line do not have work, that they can go to the South Test Cell to help them out.
Thanks.
Other questions?
The readout was on the DC side. Is there one on each side, the big, large screen readout? Yeah, that's correct. What we saw in the presentation was just the DC side, but within the report and for the proposal, we're recommending one for both sides, so we can capture that data for both of them. Does that answer your question, Mr. Wood?
All right, any other questions? Well, let's give them a hand.